This allows bodies to relatively move forever as long as they don't collide with any obstacles because they are made of motion. The inertia of bodies simply represents the amounts of movement they are made of. That's what they are. All bodies are the situations of movement they present. A rigid or impenetrable body means a fixed, constant amount of motion that does not change. I define movement as a change of place. We can define movement as a movement of a body from one place to another. Newton. There is no physical experience in the universe capable of distinguishing a situation of rest from a situation of uniform rectilinear motion. There is also no physical experience capable of distinguishing these two situations, rest and uniform rectilinear motion, from a situation of free fall in a gravitational field, which is a situation of accelerated motion, as well as a situation of rest. Although locally we observe different types of movements, for the universe as a whole, due to the same nature of all concepts in physics and due to the continuity of space, no displacement occurs. Everything is always one and the same rest. The validity of all physics concepts is always locally limited. It always depends on the reference used, as shown by relativity. Although for the universe, the definition of motion as being change of place doesn't mean anything or has no importance locally, such a definition is always valid and important for us. To say that a body moves from one place to another, to say that a body changes its place in space due to the always the same nature of these concepts involved, means only comparing quantities that appear to be different things, but which turn out to be identical or equivalent. The comparison is always allowed by the inexistence of a rigid, fixed, absolute standard of rest within the universe, by the continuity of empty space. It is particularly interesting that the speed of light is always constant regardless of the relative speed of the source and the observer. The fact that the rhythm of time passes at different speeds according to the composition of movements observed, always exactly inversely proportional to the speed of the observed moving body, reveals that time is also a type of movement. This reveals that there is a profound identity, equality, or equivalence, and unsurpassed between the type of movement that is light and the movements that are the particles that constitute bodies. Light and matter are made up of one and the same nature, the movement. The speed of light is always constant and independent of the speed of the source and the observer, because the movement that is light is a movement very simple, so simple that it doesn't even admit compositions of movements, unlike matter. Space is distinct from the body. Motion is something that happens with respect to the parts of that space, not with respect to the position of neighboring bodies. Newton. Newton is rarely wrong, but in this case, he was completely wrong. Newton, like us, is also a human being. A space is not distinct and not totally independent of material bodies and vice versa. If matter would have a different nature from the nature of space, and if that were the case, it would be unlikely that a situation of rest would be completely physically equivalent to a situation of uniform rectilinear motion and a situation of free fall in a gravitational field in the absence of air. Fortunately for logic's sake, and ours as well, matter has the same nature as space. This is demonstrated by the constant and exact proportionality always present in the equations of classical physics between these two concepts, acceleration in relation to mass, for example, as well as the constant and exact proportionality between these two concepts always present in the relativistic equations. Decrease in length in relation to the increase in mass when at speed, for example. It is impossible to define movement in relation to parts of space, even because parts of space do not exist. Space is continuous. All motion can only be defined in relation to the positions of neighboring bodies. It is always about relative motions only because, as Einstein's first postulate states, uniform absolute motion cannot be detected. Thanks for watching. Subscribe to my channel and give your like if you enjoy it.